applications of quadratic functions. So, let's just do a few examples of these. You will see ones like this or different. The sum of the squares of two consecutive
there's a whole channel.
Okay, so the sum of the squares of two consecutive integers, 481. What are the numbers? So how are we going to start this?
Application. You guess it.
How are we going to start this?
X plus x plus 1.
Yeah, x squared plus x.
2x squared plus 2x plus 1.
No, I want to, before all of that, before any of that, what are we going to do first?
Let x be.
Yeah.
Oh.
So we need to start off by defining our variables, right? Now, you can define variables in a number of ways. You can use a let statement, which is what's appropriate here. You can use a table, as we did for like distance, speed, time problems. You can use a diagram and show the variables on the diagram, okay? But somehow you need to define your variables, okay? So what are we going to say? Let the integers be, well, how about this? Let the first integer be what? X. And the second one, x plus 1. Which you'll note, I'm going to put in parentheses, right? Because what are we now going to do with x and x plus 1? We're going to square them and add together. So the sum of the squares of two consecutive integers is, which in math translates to equals. Okay, so word problems. First step is define your variables, table, diagram, let statement, whatever, right? Just so somebody looking at the solution understands when they see this x squared plus x plus 1 squared, what the heck is x, right? And now we do it, right? So we get x squared plus, okay, I don't need brackets here now. Okay. And now we're at the 2x squared, right? Which is where some of us were right at the beginning was, hey, yeah, here's the formula, right? But so 2x squared plus 2x, then what? Minus 480 is equal to 0. Okay, what's the next line I'm going to write?
A equals 2, B equals 2, C equals 3.
Nope.
Divide by 2.
Divide by 2. So what's the next line I'm going to write?
X squared.
X squared. Minus 240. What?
I did say.
Okay, and now,
See if you can factor it.
see if you can factor it. Well, they're integers, so it has to be factorable, right?
Yeah.
Okay. Now, you could use quadratic formula. I'm not going to because I know this factors. I mean, if it solves, it factors, right? If there are, in fact, two consecutive integers that do all of that. All right, so there's a positive factor and there's a negative factor, and the positive factor is bigger. And seeing as they're consecutive, what I would do is start with the square root of 240. What's the square root of 240?
12.
15 point something. So then the numbers are probably 16 and 15.
Oh, I was right.
Congratulations.
Woohoo.
What if he's wrong?
What if he's wrong?
Okay, guess. This is guess. Now you check. x squared
Yeah.
minus 15 plus 16 is plus 1, and that gives you minus 240, so numbers are good. So what's my answer?
X equals negative 16 and 15. Or yeah.
So, does that answer the question?
But seriously, how was the cake?
Because the question is, what are the numbers, right? Why did I go to another page? I wanted to extend this page. So the question was, what are the numbers? So what are the numbers?
Negative 15, 16. That doesn't work. Plus or minus 16.
The numbers are?
Plus minus 15. Plus minus.
Okay, go back to the let statement. What's x?
Negative 16.
No, what's x? The first integer.
Oh, 15.
So the numbers are negative 16, that's x. What's the second integer?
X plus 1.
Which is?
Minus 15.
So the numbers are negative 16 and negative 15, or?
Plus.
Or 15 and plus 16.
Okay.
I told you.
Last step in solving is to look back. So first thing we got to realize here is, hey, I have two possible sets of numbers, right? That the solution gave me two x values, but x is simply the first integer. So the number that goes with that is one more, right? X plus 1. So negative 16 and negative 15. Okay? Now, is the sum of their squares, so 256 plus 225, that's equal to 481. And 225 plus 256 is equal to 281. 481. So your check back, yeah, he's been on there for like 12 years. What is this? It's a Pokemon Pikachu GS2.
Where?
This.
Oh. Pokemon. Gotta catch them all.
Last step is to look back, right? Do we have the solution? Yes, we check it. Okay. Now I never do a check by going back into any expressions I wrote, because if I wrote the wrong expressions, I go back and do a check by looking at the original problem statement and saying sum of the squares of two consecutive integers. So are negative 16 and negative 15 consecutive integers? Yes. Is the sum of their squares 481? Yes. Are 15 and 16 consecutive integers? Yes. Is the sum of their squares? Yes. Okay. So then we know we've got the right answer. Okay, questions? Example 2. Find the dimensions of a rectangle.
That never gets old. We can watch like 10 of them. It's probably gonna be your side. If your side is gonna watch that, you're gonna
With perimeter 60 meters.
They should.
And whose area is 216 square meters.
Oh, okay.
Okay, so I'll give you a moment to absorb that.
Okay, so
Let
L
X
plus
be
W.
the.
2L plus 2W.
Wait.
60 and then L times W.
What? Oh, okay, I get it.
There's two variables.
Draw two.
So let's start off by drawing a picture. That's how we're going to set out our variables. What are we going to call them?
X and Y.
X and Y. L and W. L and W.
I'll go with L and W. Why not, right? So they can be anything. They could be X and Y, it could be L and W. It doesn't really matter, right? But in this case, we're basically saying the length of the rectangle is L, the width is W, right? That's the information that we've given out. Now, what information are we given in here that we're going to use with the L and the W?
2L plus 2W equals 60.
Okay, so 2L plus 2W is equal to 60, which you immediately want to change that and write what?
L plus W equals 30.
Yeah, so L plus W is equal to 30. And what else do we know?
That L times W is 260.
L times W is 216. No. At this point, we don't put units. Not physics, sorry.
It's okay, I'm not taking physics yet.
All right, when you do, then you got to put units on everything.
And no, it's
In math, we don't. We'll understand based on everything up there that that's the 216 meters squared. Okay, how are we going to solve this?
Systems.
No. Well, yes. Yes and no.
You could do it both ways.
So we're just going to solve this equation for one of the variables. Like L is 30 minus W.
So
We're going to substitute it in, so it is a system, yeah.
You lied to us.
Yeah.
Wow.
So we are solving a system. We have two equations and two unknowns, but we're doing it by substitution, right? So L is 30 minus W. Where we see L, we're going to write 30 minus W. We're going to expand this and get 30W minus W squared equals 216. We're going to put this into quadratic equation, right? It is, equals 0. So what am I going to write? W squared minus 30W.
Plus 216 equals 0.
Okay, so we're just going to move everything over, right? From the left side to the right side, and then we're going to
See if we
switch
can-
sides at the same time. Large TLC assembly is. Does this factor?
Yes.
Okay, what's factorization?
Y minus 36 and y minus 6.
W.
216. Yeah. Yeah.
Okay, W squared plus 6 minus 36 is minus 30 minus 216. So that doesn't work.
Oh, such failure. This is where you use minus.
I almost wrote it down.
And there's a line.
What?
Minus and
Okay, if it factors, it's got to be W minus, right? Because we're getting a positive last term.
21 and 9.
21 and 9.
No, never mind.
That's 189.
18 and 12.
18 and 12. What's 18 times 12? 144 and 72, 216. Okay, 18 and 12 work. So look, if you can't factor it, what are you going to do? You use quadratic formula, right? Okay, so that's always there to fall back on. So, there's a certain amount of time that you spend trying to factor something before you just go and use the quadratic formula. But what if the test on Monday says solve by factoring?
You have to use
value.
Then you use the quadratic formula to figure out what the factors are, and now that you've got the factored form, now you can
Now just write it in. And
right?
pretend you
Look,
factored.
all you gotta do is find the roots, and then
Just
from that,
pretend you just.
yeah.
Pretend you did it backwards.
Look, so a couple things. One, it's probably going to be relatively easy to factor anyway, so it really shouldn't take a whole lot of horsepower, but
I think it's 2 horsepower.
you know.
2 horse brains. 2 horses. 2 horse brains.
It'd be a round 3 week, hard cutter swing. Jazz 3 week, hard cutter swing.
One day you're doing like
Okay, what do you got to say about this? Oh wait, that's 12. Sorry. Yeah,
Are you allowed to write W equals 18 comma 12?
sure.
Yay!
So, it wants the dimensions of the rectangle. What are they?
Well, 18 and
12.
18 and 12.
Not really. We have two sets of identical answers.
35.
The dimensions of the rectangle are?
18 and 12.
Oh, do you need a word sentence?
Or.
Right? It's either the length is 18 and the width is 12, which generally we tend to think of length being longer, right? Because it's long.
Yes.
But the length could be shorter, so in this case, either the width is 12 and the length is 18, or the width is 18 and the length is 12, but either way, the dimensions of the rectangle are 12 by 18. Okay? So these two solutions are really only one solution. And that doesn't mean that every time you do one like this, that's how it's going to come out, that, oh yeah, it's exact, just these two numbers are the dimensions. You need to think about it and put it in the context of the scenario.
He gets a negative.
Step 3. height of a football as a function of time is given by h of t is equal to negative 5t squared plus 20t plus 1, where h is the height in m, or meters, and t is the time in seconds. Is there a question here you're now asking? And the question is,
Physics.
what is the height of the ball?
That's like asking the width of the universe with a mouse.
We know the mass of the universe. Gave it to us. He also gave us the radius of a proton. No, wait. I have a problem with that.
Okay, so first we're going to start with just asking, what's the height of the ball at 0 seconds? What's the height of the ball at 0.5 seconds? How do you figure that out?
Well, the height is obviously.
Wait, hold on.
Whatever is time
What if it's like 10 meters above the ground at 0
Can't you just substitute it?
It's not.
Okay, well, obviously at 0, everything will be 0.
Well, 0 is, yeah. Yeah, 0, I told you, substitute everything. See, I told you.
One, whatever you did. Didn't say to me anything. I didn't do anything.
I told you substitute it.
I didn't say anything.
So,
Why would it be 1 meter?
the height is
Oh my god!
Constant.
I know that, but it's 0 seconds.
So at 0 seconds, you're kicking the ball, which you have released, and it's 1 meter high. It's kicked, though. It says kicked. And this could be a North American football, or it could be a
No, it's England.
it could be a soccer ball. Right. It doesn't really matter. It's just a ball that's being kicked.
And then substitute 0.5.
The height is 0.5.
5.
And this works out to. What?
1.25, no, negative 1.25 plus.
12.25.
Please move, please. I cannot see.
Damn it.
18.
Try again.
Okay, plus 10.
Did I get it right?
1.25 plus 10 plus 1.
It can't be 19. This is 10. Plus 1 is 11, from which we're subtracting something.
9.75.
Thank you.
Oh, I was close.
I got 19.75.
Okay? 9.75 meters, right? It's already substituting into the function of time, its height as a function of time.
I think we should just protest.
So until we hit vectors and parametric equations, which will be a while yet.
See, I got it right.
I think we should just grab this.
B. At what time or times so when we do this, it implies there is one or more answers, right? At what time or time. So when we say to you on Monday, state the x-intercept, bracket, s bracket, you know, there could be more than one, there could be one. You know, state the relative minimum or maximum points, could be one or more. So what time or times will the football hit the ground?
What?
Oh, okay.
So when does the football hit the ground?
That's the same thing as finding a 0, right?
That's the same thing as finding a 0. Exactly. That's really what we want, right? Is we want the 0 of the function.
I think we should still grab that.
So we've got this function, right? H of t. And what do we want to do?
Factor.
What do we want to write? 0 equals, right? So we want to find the time when the height is 0. Now, there will be some negative time, right? I mean, because we know this is a parabola, and if it was kicked at 1 meter, if we continue the parabola backwards, but that won't be part of our solution, right? So that will be an inadmissible solution because in the context of the problem, it doesn't make sense to have a negative time. Had the football itself suddenly leapt off of the ground and kicked itself at a height of 1 meter, then we could say, well, it started leaving the ground negative, you know, a second before it kicked itself.
Then you kicked it.
What?
Wait, what?
Okay, what are we gonna do?
Factor it. by traditional methods.
All right, so then I would rewrite this as 5t squared minus 20t minus 1 equals 0, because I like my a's to be positive.
Is factorable?
Are there two numbers multiplied by 5? Okay, I don't think it factors.
Yeah, so quadratic formula.
That's what you think. Quadratic formula.
So we use the quadratic formula, right?
B plus minus.
B squared minus 4ac over 2a.
Aha, I got it right.
So in this case, it'll be t is equal to negative b. Oh, wait. Ready?
Oh god.
No.
Oh yeah, I got it. Oh no.
Hey, I'm not giving it to you Monday, so you can walk in singing it.
Hold on.
T is equal to negative b plus or minus square root.
He's recording this.
Yeah, don't worry. Well, you guys will. You guys will.
This is how not to do this.
Yeah.
It's like
We could go find a YouTube video of somebody singing it actually.
No.
Of a class of perhaps non-IB students who can sing.
That was insane. At least something was insane.
No one can that at least was kind of in tune.
Better than that still.
Okay, 20 squared. 420.
Hey, while we're doing this, let me let you in on something which you've probably already figured out, or I'll point this out and you'll go, oh, hey, that makes some sense now.
You already have B. Well,
So there's a couple things to worry about here. So one is, okay, does this have real roots? Well, it ought to, right? I mean, we know that because the scenario makes sense. The parabola does open down, so we know that, yeah, this likely, and this, if the scenario makes sense and all of that. So, okay, we know that b squared is always positive. If we make a positive, then if c is negative, then this will be added and there will be two distinct real roots, right? So if you're looking at an A, B, C, no matter what B is, if A is positive, and generally speaking, I'm always going to write A as positive just because I like it that way. So I'm not divided by negatives. Well, I can't top that. So if A is positive, if C is negative, you have two distinct real roots.
Yeah, because they add together.
If C is positive, then you may have 0 under here giving you two equal real roots, or a negative giving you no real roots, right? So if C is negative, A is positive, we know we have two distinct real roots. If C is positive, then it's either 0 or negative, right? So, okay, so we get 20, 420 over 10.
So what's 420? It's 420. I'm pretty sure
Cat
it's
squared.
Why do I do that?
you can't get this.
I just said it's
All right, well, 4 goes into it, but does anything else go into it?
9.
16?
No, I tried it. Doesn't
No? 64?
Nope.
No? All right, so what is it, 4 and 13 then?
Yes.
So 2 root 130? 105.
105 is a root.
Well,
Yeah.
I guess being as 105 is prime, then yeah, nothing larger than 4 would go into it, right?
How did you know 105 is
It's not. It's divisible by 5. Being as 105 has factors of 3, 7, and 5,
Oh my god.
nothing else is going into it, so we don't have to worry about it.
Okay.
Okay, so if it asks for exact values, this is what it looks like,
Well, simplify.
right?
By 2.
But it's never, yeah, simplify. Oh, right, simplify. So if it asks for exact values,
Over 5.
And then the solution is we don't want the negative, right? Because that would be a negative time.
Why are you destroying the negative? He never did anything mean to you.
He was negative, Grant.
Why did you put the negative in?
Okay, generally speaking, we're talking about times. We're probably going to want it rounded to the nearest tenth or hundredth. So let's go with the nearest hundredth. 4 point what?
4.05.
Or use the negative values.
Yeah,
Come on, the negative value, man.
I'm gonna use this.
You want the negative value.
Oh God.
Okay, and the negative solution is rejected based on context.
I just say subscribe through it. Yeah,
Okay.
I'm giving it to you, and you have to mark it blind.
So it probably is negative 0.05, right? So negative 0.05 seconds before it was kicked. The ball was on the ground. Unless it was the Canadian goaltender of the Olympics, then she held it too long, and they got a penalty shot, which is totally not deserved.
She is. Morgan is actually.
Good job.
Now this is amazing.
And this explains a whole lot about math marks in here. So. Okay, C.
Wait, there's more?
There's more.
What time is the ball the highest?
I feel like
Will the ball
So at what time or times will the ball be at a height of 15 meters?
10 times.
How do we solve this?
You have to make age.
We have to make age 15, right?
Once again, I think we should just graph.
Yeah, I think
It's about 10 times easier.
I know
Yes.
that also.
If only we weren't asked for algebraic solutions to stuff.
Well, it was
No, it
asked
didn't.
before.
Then we could just graph.
Find the answer.
Yeah, actually.
So 5t
It
squared
doesn't say determine. We can just give the answer.
minus 20t
No, I just minus 14.
plus 14 is equal to 0.
Factorable.
Probably not.
That's what you.
So, you know, you get to decide, do I want to try factoring this? And so I got to multiply to 70s, 4, 7, and 2. And yeah, okay. Yeah. And it doesn't actually factor. You could actually try graphing it and finding the zeros, or graph y1 equals that and y2 equals 0, and find the intercepts. And if they work out to nice numbers, then you've got your factors, then you can factor it. And if they don't work out to nice numbers, then you know you got to use the quadratic formula. Okay? And if you want to, having done this algebraically, if you want to check your answers, then you can solve this graphically and check your answers, right? To the nearest, whatever, 10th, 100th, whatever it is you want it to be.
I don't think it matters which way you do it.
You're the one who wanted it.
What?
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 What? Something and.
I'm hearing strange things from over there.
Yes, I'm trying to ignore them.
Well, you should.
It's almost 11, guys.
Almost 11.
No, it isn't.
It says right there it's 11. I trust the computer.
I trust connected all
400 minus 280.
Yeah.
I just
120.
Still 10.
I just. Also sells it.
Yeah.
Computer's library is half empty or half full, depending on how you look at it.
No, it's completely full.
No, look at it.
Half of it is filled with the liquid, and half of it is filled with the gaseous.
Now it's 11.
And you have to exclude the negative.
No,
No, you don't.
there isn't a negative. Root 30 is what? Like 5 point something?
No, I meant the plus or minus.
6 or 1 to 4.
Yeah, root 30 is what? 5 something?
I see.
So 10 plus 5, 15, 10 minus 5, they're both positive times. Okay? So both of these are positive times, right? Because root 30 is somewhere between 5 and 6. So 10 plus, let's call it 6. 10 plus 6 over 5 is positive. 10 minus 6 over 5 is positive. We should be getting 2 times, right? Because the path of the ball, or the ball with respect to time, should look like this. And there's 15 meters. And so there should be 2 values. Now that's how you would check on your calculator, right? Y1 equals the quadratic, or sorry, you could just graph this and look for the zeros, or you could graph the original. So going back up here.
You can graph your original, go into your table.
You can graph y1 is this, y2 is that. Look for the intersects.
Yes, intersects.
Okay, so rounded to the nearest hundredth, what do we get?
0.10. Okay, 0.10.
So 10 plus root 30 over 5, which is how much? 3 point. And 10 minus root 30 over 5?
0.9.
Okay, any word problem should be answered with a sentence at the end, right? Laying out the solution.
We have to. Yes.
Yeah.
It's not so hard.
Well, one of the main reasons.
Well, no, you don't have to. You just get a mark for it.
Yeah, you don't have to. I don't have to give you marks for it. One of the main reasons is if you stop that first question at negative 16 and 15, you're not actually answering the question. So the question is, what are the integers? So you need to list them. The integers are negative 16 and negative 15, and 15 and 16.
What did you write that? Or not add. It can't be all the values.
Right. The time at which the ball reaches a height of 15 meters.
Yeah, because I want it.
I don't need to see it either.
One question is to technology.
Yeah, I don't know your name. Your name is.
Okay, so according to the outline,
We're done.
Video is still going.
back side of the outline.
We got 2 quizzes.
Tuesday, so.
Right. So
What?
Monday. So this stuff not on the quiz.
Why not? It's a lot easier.
There are no applications. The quiz is up to and including discriminants. So you might want to spend today and the weekend studying for the quiz. Monday is the quiz and Tuesday is a work period on this stuff. Okay, so
The video is
you use your time as you see best fit.